Let's talk about something you've definitely seen. You put a straw in a glass of water, you look at it, and something's just not right. It looks bent, maybe even broken, right where it hits the water. Well, today we're going to solve that little everyday mystery.
Yeah, this one. You've seen this a million times, right? You stick a pencil or a spoon into a glass of water, and bam, it looks like it's snapped in half. It's this classic, weird visual trick, and it happens every single time. So what is actually going on here?
Okay, first things first. Your pencil is totally fine. Phew. What you're actually seeing is a fascinating illusion. It's basically a cool trick that light plays on our eyes, and the secret behind it all is just pure physics.
All right, so let's get right into it. The entire explanation for this, from the straw in your soda to the floor of a swimming pool, it all boils down to just one single powerful word. And that magic word? It's refraction. So what is it? Put simply, refraction is just the bending of light. That's the whole deal. It happens anytime a ray of light crosses the boundary from one material, like the air, into a different one, like water. The light literally changes direction.
Okay, but why? Why does the light bother to bend in the first place? Well, the reason is actually surprisingly simple, and it all comes down to one thing: speed.
Think of it like this. Imagine your car driving off a smooth, paved road and hitting a big patch of thick mud. You're going to slow down, right? Light does the exact same thing. It zips through the air really, really fast, but the moment it hits the much denser water, it has to slow down.
And that key moment, the place where all the action happens, is right at that boundary, that shimmering surface of the water. That's the spot where the speed of light suddenly changes, and that change in speed is what literally forces the light to bend.
So to really get this, let's go on a little journey. We're going to follow one single ray of light, tracing its path from the part of the pencil that's underwater all the way up to your eye and see exactly what it's doing.
Okay, ready? First, light bounces off the submerged part of the pencil. Then it travels in a perfectly straight line through the water until it hits the surface. But right as it breaks through into the air, it speeds up, and that sudden acceleration causes it to bend. That newly bent ray of light is what finally travels into your eye, and that's the signal your brain has to work with.
Now that's only half the story. The real trick happens inside your head. It's not just that the light bends. It's about how our brain tries to make sense of that bent light. This is the final piece of the puzzle.
So this is what's physically happening. This is reality. The light ray comes up from the pencil, hits the surface of the water, and then takes a sharp turn before it reaches your eye. It follows a bent path.
But here's the kicker. Your brain has no idea the light took a detour. Our brains are hardwired with a very simple rule. Light travels in straight lines, always. So when it receives that bent ray, it just traces it backward in a straight line and ends up creating a virtual image of the pencil tip in a place where it isn't actually located. That's why it looks broken.
And once you see this, you can't unsee it. It's literally everywhere. It's why your spoon looks wonky in your morning tea, it's the pencil in the glass, and it's also why the bottom of a swimming pool always looks way closer and shallower than it really is. It is all the same incredible physics at play.
So, if you remember just one thing from all of this, let it be this. The next time someone asks you about this, you've got the perfect, simple answer. Objects look bent in water because light itself bends when it moves from the air into the water. Simple as that.
And that kind of leaves us with a pretty wild thought, doesn't it? I mean, this is such a simple, everyday illusion, but it shows us that what our eyes report to our brain isn't always the truth. It really makes you wonder, if our perception can be tricked this easily by a simple glass of water, what else might we be misperceiving every single day without even realizing it?